In the previous video lectures, we have seen about the capture compare module of PIC microcontroller. So in this video lecture, we are going to see about the PWM output of PIC microcontroller. So PWM is nothing but pulse width modulation output. So you have already seen about this pulse width modulation in the linear integrated circuits. In that, using IC 555 circuit, you have taken an pulse width modulated output. Okay, using that 555 IC, you have framed a circuit. So for generating this pulse width modulation output. So how this output will be is, so it will be like the pulses. Okay, so it will be like the pulses, but the period may vary. See here this is the on period and this is the off period. The total time period is not the same in every cases. Here it is different, here it is different, here it is different, here it's also different. So here this pulses duration has been varied while it has been generated. Fine. So this is our pulse width modulation output will be like. So using this timer that we have already discussed in PIC microcontroller, we are going to generate an output like this. So the use of this output, we will discuss it later. First we will see how we can generate the output like this. Fine. So for capture and compare module, we have used timer 1. Fine. So for this PWM, we are supposed to use only timer 2. Okay. So already we have discussed the timer 2 operations. So it do have its pre-scalar, main scalar, post-scalar values. When these gets overflowed, the interrupt will occur. This is what the operation of the timer 2. Fine. So here we will use this timer 2 to generate this PWM output. Fine. Okay. So how it will generate, we will see it. So this will have two periods. One is on period, another one is off period. So for this, we are supposed to give and predefined on period value to the timer and off period value to the timer. So when this value has been matched with the timer values, we will get an output like that. We will see it now. Okay. So this PWM output module will be selected by using the register CCP-con register. So this we have seen already. Fine. So this is the CCP-con register. In this, it's an 8-bit register. Here at the lower 4 bits will decide the mode. So if this value started with the 0, which means that I am using it for capture 1. 0, 1 is for capture. So 1, 0 is for compare. We know it already. Okay. So when this value started with 1, 1, it is meant for PWM module. Fine. So if this 4 bits value is 1100 or 1110, any of thing. Okay. If it starts with 11, which means that we have dedicated the timer module for the PWM output. Fine. So and these two bits are also used, bit number 4 and bit number 5 is also used in PWM. So how it is utilized, we will see it later. Okay. So using CCP-con register, we are supposed to select the module, PWM module. So next we will see how the output is generated using timer 2. Fine. So see this. So this is used to select the set period to give this high output at the pin number. Okay. So since we are using timer 2 and we are generating PWM output, we are going to generate it through the pin RC2. So if we use CCP1 module, the PWM output will be generated in RC2. If we use CCP2 module, the output will be generated in RC1. So RC is nothing but port C. Fine. Port C first pin for PWM second module, for PWM first module port C second pin. Fine. So here we have taken CCP1. Okay. So here we have a timer module which has its pre-scalar, okay, 2-bit prescaler, it can be either 1, 4 or 16. Any of these 3 values we are supposed to give here, and we will give our clock as an input. Fine. So when we give our clock here, okay, so based on the prescaler, the timer value will be incremented. Fine. So whenever it's getting incremented, it will be compared with the PR2 register. So in this register, we will have our predefined value. Okay. So this PR2 will have the total period of the PWM. Okay. So what do you mean by period? If this is our PWM output in the sense, so on and off will constitute a period. Fine. So this total time should be mentioned in this PR2. Okay. So if we give our input clock pulse to this timer 2, it will be incremented. Whenever it is getting incremented, it will be compared with this PR2 register. Fine. So this PWM we are supposed to give as 10-bit value. Okay. So that's why we have included 2-bit prescaler. Okay. So here PR2 is an 8-bit register. So we are in need of another 2 bits, and that must be 1 and 1. Okay, it is already defined. It should be 1 and 1 and not any other values or should be used. Along with the 8-bit value in PR2, this 1 will be considered. Okay, so these 10-bit as a whole, 10-bit will be compared with the timer and the prescaler value. So whenever it's receiving the clock pulse, it will be incremented and compared with the PR2, which is nothing but the total period here, the total period of the pulse. So if we find, for example, if we have a value 0.5 here and 0.5 also here, so the value has been matched, which means that the period of this pulse is 0.5. This we have stored in PR2. Now the timer is also 0.5. So this has been compared. Fine. So now these two values are equal. So what it happen is, so it will set, we will use the SR latch with the RC2 pin. So what it will say, do is, it will set the output, okay, output to high. So this will be our output if the values in the timer 2 and PR2 are get matched. Okay, fine. So now what we are supposed to do is, so this set time, this has to be, this high values has to be retained for some period, no. So this we have to give in the register CCPR1L. So since we have used module 1, I am supposed to use CCPR1 register. Fine. So this on period T on should be mentioned in the CCPR1L register. Fine. So once again I will recollect this part. Okay. So the total time period of this pulse width modulation should be stored in PR2 register along with the values, 2-bit values 1 and 1. Okay, whenever the clock pulse is given as an input to this timer 2, so whenever it gets incremented, it will be compared with PR2. Okay, when the values of these two registers are equal, so this will set the output at RC2 as high. So this is what will happen at this part. Fine. So this part will tell you how long this on period should be on period should be retained. Okay. So this on period we should write in the register CCPR1L. So this will be automatically, see here, this will be automatically loaded into the CCPR1H register. This is lower byte and this is higher byte. This value will be loaded into the higher byte register. Fine. So this will define how up to how long period this high pulse should be retained. Fine. So as I already told you, it is a 10-bit value. So this is an 8-bit value. Another 2 bits it will take from the CCP1 control register. Okay. So see here, CCP control register, and this bit number 4 and 5 will define the 10 bits of that CCPR1. So this is what I have told you. In this same register, CCP1 con register, 4th and 5th bit will give you total 10 bits of the total on period. Okay. So as of the set time, okay, thus we have discussed previously, no. Here also we will give our input clock. The prescaler value should be defined in timer 2 control register. So since we are using timer 2 control register should be used. Okay, fine. So this will give us whether the prescaler value is 1, 4 or 16. Fine. Okay. So if this is 0 0, it is 1. If it is 0 1, it is 4. If it is 1 0, it is 16. So that prescaler value is defined here, and then the timer register. So if we give a clock pulse, this timer will start to count. Okay. So whenever it is incremented, it will be compared with the CCP-R1 higher byte register. So if the match is found, we will take the same value like 32 here, okay, 32 also here. So when these two values are matched, okay, so this will generate an output signal that is given to the reset part of the SR latch. Okay, so this SR latch is connected with RC2 pin. So what will happen? So because of the previous circuit we have discussed, we will get the R rise edge. That means it will be set that the output will be high. So during this period until the match is found, this high will be retained. Okay. So once this match is found, so I am giving input to the reset pin. So what will happen? This signal will be resetted with the value 0. Okay. So this is the T on period, and this value is given in CCP R1L register. Okay. So whenever the match is from, this value is reloaded with the value from the lower byte register. So if you want to change the on time period in between the timer is running, you can do it, but you can write it only in the CCP1 lower byte register, not in higher byte register. Fine. So this is what will happen for generating the PWM output. Okay. Since we are generating the output through RC2 pin, so we have to use the TRIS register to set the RC2 pin as an output. So this is the second pin, so it should be written with the value 0 so that that pin is configured as an output. Fine. So this is how the output will be generated using timer 2. Fine. So the total time period is given in PR2 and the on time period is given in CCP-R1 lower byte register. So that circuit PR2, okay, that circuit will define the starting high pulse. Okay, so the starting time of the high pulse. So the duration of the timer on, okay, that on time, okay, the duration of the on time is given in the CCP-R1 lower byte register. Fine. So using these two things, the output will be generated. Fine. So the output we have discussed. The important terminology that we want to know is duty cycle. So what do you mean by the duty cycle? In the sense, the total percentage of on time period of the pulse with modulation is known as duty cycle. Fine. So duty cycle we will always mention in the percentage itself. Okay. So the duty cycle is equal to T on period, okay, divided by the T on plus T off, which is nothing but the period, total period into 100%. So from our circuit, we have already seen the period is given by the PR2 register. So that can be derived using this formula, PR2 plus 1 into prescaler value divided by the oscillator value into 4. Okay, prescaler value is defined by us by using the register timer 2 control register. Okay, using either it can be 1, 4 or 16. It depends on the programmer. Fine. And the oscillator also maximum we will use 4 megahertz. So that has been fixed here. Okay, the oscillator value will be 4 megahertz. It can be of 10 megahertz and it can be of 11 megahertz. Fine. So using this formula we can calculate the period. Okay. So for example, if the oscillator frequency is 4 megahertz and the prescaler value that has been fixed is 4, then the period, which is nothing but on time plus off time, is given by the formula 4 into PR2 plus 1. So using this value we can define it and we can store it in the PR2 register. Okay. So and then the T on period is given by 4 into CCP-R1 lower byte plus 2 into CCP1X and C plus CCP1Y. So these two bits are nothing but CCP1 con registers, bit number 4 and bit number 5. This we have seen. So this is bit number 4 and this is bit number 5. So the value in this register will be multiplied by 2 plus the CCP R1 lower byte into 4 will give us the T on period. Fine. So when we divide that T on by period will give my duty cycle in percentage. Okay. So this is how we will derive or calculate the values that has to be written in CCP R1 register and then PR2 register. Okay, that will define the duty cycle of the pulse width modulated output. So why we are generating this pulse width modulation output? In the sense, using this pulses we can drive another circuit that we can connect with this PIC microcontroller. So we can connect the motor, we can change the speed of rotation of that motor, revolution per a minute. So that can be decided by varying this pulse width modulation. Okay. So this, if you see it will be quite similar to the digital to analog converter. Okay. So see here, the value that we write in PR2 and CCP-R1 are nothing but the digital values. So those values are only determining the duty cycle of the PWM output, right? So the digital values that we write in these two registers are generating the output, analog signal as an output. So the digital value that we are writing in the register is responsible for generating the analog signal, right? So this is quite similar to digital to analog converter. So that's the one of the purpose of PWM. Another purpose is you can drive the another circuit that we can connect with this PWM output pin. Okay, so we can change the speed of the motor, or else we can connect the LED and change the on and off time period frequently. So either of these things we can do it with the pulse width modulated output. Fine. So I hope that you guys understand the concepts of microprocessor and microcontroller. So as a whole gist of this course, so what we have seen is, so we have seen two processors, one is 85 and other one is 86. So in detail we have seen about its architecture, addressing modes, instruction sets, memory organizations, timing diagram, and then interrupts of these two processors. Okay, so we have seen all these things in detail, and then we have seen about the peripheral devices that we can connect with these processors. So we have seen about programmable input output, that is 8255. We have seen about keyboard and display controller. We have seen about the dynamic memory access, analog to digital converters. So these things we have seen. And then fourth and fifth unit we have seen about the microcontroller. So in specific we have seen about the PIC microcontroller. Fourth unit, the features, registers, instruction set, and then the addressing modes we have seen. And in fifth unit we have seen about the timers of PIC microcontroller. So the different timers and the different modules of PIC microcontroller. Fine. So this is what about the whole course of microprocessor and microcontroller. Hope you guys understand the concepts well and do your exam good.